here's what we got here. So just got another word problem. Okay, you guys are going to see a word problem on that summative assignment there. Okay. What this also does for us is we're allowed to, or it allows us to practice our factoring skills. Okay, so a ball is kicked upwards and its position relative to time can be represented by the equation h equals negative 5t squared plus 20t. Okay, where we're going to say h is height, okay, and t is time. Okay, so we're going to factor this. Okay, and I've tried to scaffold this question in a way that you're going to do it in the order that I think is going to step you through it. Okay, so you're going to factor this by finding the greatest common factor. Okay, this is the same kind of thing that we did earlier. So we're looking at that equation. We're going to say, okay, well, what? I'm going to write it out again just so we have it. T squared plus 20t. Okay, and you're going to look at that. You're going to say, okay, what's the biggest thing, both number and variable, in this case t, that I can take out of both of those? Well, it turns out that I can rewrite this as taking out the negative 5t. Okay, I look at both of these and I see, okay, there's a negative 5 factor that goes into both of those numbers and also a t, right? So then you're like, okay, if I were to remove that greatest common factor, then what would be left on the inside of those brackets? Well, you'd have to go, and maybe I'll just move this down. I'm just getting the habit. Sometimes, like, if you guys want to do it this way every time, it kind of helps me anyway, or at least helps me teaching it anyway. It makes sense to me. If I go divide by that greatest common factor, you guys can do the math on it. Negative 5 cancels with the negative 5, so that's just a 1. And then 1t cancels with 1t in the top, so we just get 1t. 20 divided by negative 5 is negative 4, and the t cancels with the t. So you're just left with a factored equation that looks like this. Negative 5t, t minus 4. Okay? Any questions? You could then tell me, okay, well, if I asked you, oh, I did ask you, so we're going to wait to do that, but that's us in factored form, okay? Okay. Remember, factored form tells us about the roots or the solutions or the x-intercepts or zeros. Any of those four things all mean the same thing, okay? So the next question here is like, well, how high is the ball at 0, 1, and 2 seconds? That's what we want to know here. Well, what you could do, and you can make a decision. Remember, we talked about how these two things are the same. These two equations are the same. They give you the same graph. But sometimes, like, I might choose to use one over the other for a variety of different situations. In this situation, what you're being asked to do is find, like I suppose in other words, this is saying find h if t is equal to 0, 1, and 2. So you're going to have three different answers here, right? You're going to say, okay, I have an equation that's telling me what height is equal to, and I have a spot to plug the t into. So why don't we do that? Well, let's just check the first one. So h equals negative 5t t minus 4. I want to figure out what the height is, h, if I plug in t equals 0. So let's try that. What's 0? 0 times negative 4, which is equal to 0. All right, so that means when t equals 0, h equals 0. Let's try the next one. it wants us to find what the height is when t equals 1. Let's do the same thing. H equals -5 times t minus 4. Plug in 1. -5 times 1 times 1 minus 4. -5 times -3 is equal to 15. All right, that means h equals 15 when t equals 1. All right, the last one's asking us find the height after 2 seconds. Well, let's plug in t. T equals 2. H equals 5 times 2 times 2 minus 4. That's 10 multiplied by -2, which is equal to -20. Did I do that right? Nope, sorry, I forgot a negative. I was thinking about that. Remember, the very start of this has a negative on it, right? So that's going to be -10 times -2, which is +20. Okay? So h equals 2. Oh, sorry. What did I write over here? Yeah. H equals 20 when t equals 2. These are all points. Input, output, like your table of values, right? From formative 5, which I'm going to show you in a minute. Okay. Okay, so you now have, from part A, you have an equation that represents the height as a relative to time, okay, but you've factored it in a way that it'll spit out your answers, right? And so we're going to say h is equal, I'm just going to rewrite it. Okay, and then you're going to say, okay, I could rewrite this, and you could say, okay, plus minus what? Well, sorry, not plus minus. It'd be the t values, or the roots, or x-intercepts, are always going to take on the opposite values that you see there. All right, well, t is going to equal -0 from the first one, right? Which is just 0. And then t is going to equal 4, which means after 4 seconds, the ball okay. So besides, the reasoning, remember we discussed some of the reasoning as to why this was the case, okay? What you're actually doing is you're saying, okay, if the ball hits the ground, then h must be 0. And so your equation, 0 equals -5t, t minus 4, right? It's 0 because h equals 0, right? And then you're able to solve. You're solving for the two t values that set each of these two pieces equal to 0. Well, if t equals 0 here, then it works. If t equals 4 here, then this one's 0. Okay? That's how you know this works. Okay? Once you have this, if I were to sketch this, and like hopefully from this morning's lesson, we've kind of got this figured out now. But if I were to sketch this just roughly, right? Here's time down here. Here's height. Right? We kick the ball, it goes up, and comes back down after 4 seconds, right? So that's going to be one x-intercept, and this one's going to be the other. Now, use your answer from C, or answers, I suppose I should say, to find the maximum height of the ball and when it occurs. Well, we know the maximum height must occur at the vertex, right? Where does that vertex occur? Well, there's an axis of symmetry, right, where the parabola gets broken into two halves that are identical, right? And you're figuring out, well, where is this axis of symmetry? Well, it's exactly halfway between 0 and 4. Well, what's halfway between 0 and 4? X equals 2 is your axis of symmetry. Well, conveniently, because this question's been designed well, you already know, right? You know if this is halfway, right? You want to know, okay, well, the ball is reached its maximum height halfway. Well, what is its maximum height? Well, it's right here somewhere. Well, how do I find what the actual height is? Well, we said if we took the original equation and we plugged in, if we plugged in any value, I suppose it's not x, it's t, sorry. If you plug in any value of t into the equation, it will tell you what the height is, right, at that particular time. Well, it turns out you've already done what the height is when t equals 2. Right? That's what we did right here. So when t equals 2, the height was 20. Did we give a unit? No units. So you can say 20 units. Okay. Does anybody have any questions? Okay, I'm going to stop it here. You can ask any questions you want.